Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve this interesting question. So lower limit we have half derivative, upper limit we have infinite sum. So first we know we should evaluate lower limit and upper limit. So lower limit here I am going to take L1 and upper limit I am going to take L2. So let's evaluate L1. So first to evaluate L1, here we have half derivative of 1. So how to find the half derivative of 1? Well, let's consider the general power rule. We know d by dx x to the k is equal to k times x to the k minus 1, and we can write this is also equal to k factorial over k minus 1 factorial times x to the k minus 1. Then if we take second derivative, d square over dx square x to the k is equal to, we know, k minus 1 times x to the k minus 2, and here also we can write k factorial over k minus 2 factorial times x to the k minus 2. Similarly, if we take nth derivative, we have dn over dx to the n x to the k is equal to k factorial over k minus n factorial times x to the k minus n. So now here nth derivative. So for fractional part, if we take alpha, d alpha dx to the alpha x to the k is equal to k factorial, we know, gamma of k plus 1 over gamma of k minus alpha plus 1 times x to the k minus alpha. Now when alpha is equal 1/2 and k is equal 0, we have d 1/2 over dx to the 1/2. Here x to the 0 power we have 1 is equal to gamma of 1, we know, 1 over 1 minus 1/2. So gamma of 1/2 x to the minus 1/2. Gamma of 1/2 we know is square root of pi. So we have 1 over square root of pi x. So we know L1 is equal to 1 minus square root of pi x times 1 over square root of pi x. Square root of pi x get cancelled, and 1 minus 1 we know 0. So we have L1 is equal to 0. Now let's consider L2. So we have L2 is equal to infinite sum. N is equal 0 to infinity, 1 to infinity, here 1 to infinity, 4 over 4n square minus 1. Now 4 we can take outside of the sigma notations. Here n is equal 1 to infinity, 1 over, here we know a difference of 2 squared, so 2n minus 1 times 2n plus 1. Now partial fraction decomposition. So we have 4 times n is equal 1 to infinity. Now according to cover method, here 2n minus 1. So here we should plug in 1/2 for n. So we have 1 over 2. So 1 over 2. Similarly, we have 1 over 2, 2n plus 1. Then 1/2 we can take outside of the sigma notation. So here we have 2. N is equal 1 to infinity. Here 1 over 2n minus 1. I'm going to take 2 as a common factor. So here 2. So here n minus 1/2 minus 1 over n plus 1/2. And I'm going to add plus 1 over n. Also subtract 1 over n, because I'm going to apply the series representation of digamma function. Now these two get cancelled. So we have here, now I'm going to take minus 1 over n and 1 over n minus 1/2 and minus sign as a factor. So we have n is equal 1 to infinity, 1 over n minus 1 over n minus 1/2, then plus sum of n is equal 1 to infinity, 1 over n, then here minus 1 over n plus 1/2. Okay, now we know the series representation of digamma function. In the previous video, we proved the identity of series representation of gamma function, digamma function. So if you like to watch, I will add the link in the description. So we know digamma of 1 plus x is equal to minus gamma. Gamma we know Euler-Mascheroni constant. Here n is equal 1 to infinity, 1 over n minus 1 over n plus x. Therefore, here we have same time of infinite sums. So we have here minus digamma of 1 plus, now x we know here this value. So here we have minus 1 half. So 1 minus 1 half. Then here minus gamma. So we have plus gamma plus digamma of 1 plus here 1 half. So 1 half plus gamma. Okay, then here minus I. So now we know minus digamma of 1 half minus gamma plus gamma get cancelled, plus digamma of 3 over 2. Okay, in a previous video I also found the value of digamma of 1 half a couple of days ago, so you can watch it. We know digamma of 1 half is equal to minus gamma minus 2 times natural log of 2. Also we know the recurrence relation. We also proved this relation. Digamma of 1 plus x is equal to 1 over x plus digamma of x. Then if we plug in 1 half here, digamma of 1 plus 1 half we know 3 over 2 is equal to 2 plus digamma of 1 half we know minus gamma minus 2 times natural log of 2. Okay, then we can plug in. So we have here minus digamma of 1 half gamma plus 2 times natural log of 2. Then here plus 2 times minus gamma minus 2 times natural log of 2. 2 times natural log of 2 and gamma get cancelled. So we have 2. So we know L2 is equal to 2. So here L2 is equal to 2. Now our integral becomes integral from 0 to 2 arctan of 2 minus x over 1 plus 2 times x over x square minus 4 times x minus 1 dx. Okay, now I am going to take a substitution. U is equal to 2 minus x over 1 plus 2 times x. So if we simplify, u plus 2xu is equal to 2 minus x, and if you isolate the x we have 2 minus u over 1 plus 2 times u. So here same type of function, x is the same type of substitution. So we can write here integral from 0 to 2, here arctan of u over here now x we know equal to u. So u square minus 4 times u minus 1 du. Okay, we can take our integral is equal to I. Now here this is also equal to I, and we can change the variable 0 to 2 arctan of x over x square minus 4 times x minus 1 dx. Okay, then we know arctan of 2 minus x over 1 plus 2x. Using arctan trigonometry formula, we can write this is also equal to, so I also equal to, we know 0 to 2 arctan of 2 minus arctan of x, because this expression is equal to arctan of 2 minus arctan of x, and here we have x square minus 4 times x plus 1 dx. Now we know this is also equal to I, this is I, and now I am going to take sum of these integrals. So 2 times I is equal to, now we know arctan of x get cancelled, so we have 0 to 2 arctan of 2 over xor minus 4x minus 1. So we can write as a perfect square x minus 2 perfect square minus square root of 5 perfect square dx. Okay, then we know here arctan of 2 times. Now this integral, I think easily you can evaluate. So I is equal to here 2, so minus 1 over, now if we evaluate this integral, we have minus 1 over square root of pi hyperbolic arctan of 2 over square root of pi. Okay, this is the answer for this question. If you like this type of videos, please subscribe this channel. Thank you for watching.